Hey Yoga!
Hey! Hey, what you doing?
I'm doing the discussion for DSP, the assignment.
Oh yeah, we're doing a phase 3, right?
Yeah, right now. Phase 3.
Alright. Good evening, ladies and gentlemen. We are Group 14. My name is Yogananta, and together with me are my group mates, and they are...
My name is Abdulatif Azuli. And my name is Usaid Haris Jaafar.
And here is our discussion for our DSP assignment. So, phase 1, part 1 explains about how different FS can affect the number of samples it can take at a certain time. The greater the FS, the more samples it can take. However, one must take note that if FS is less than the number of samples, overlapping may occur, so known as aliasing. Now, part 2 describes how different signals can generate a different output given with the same number of samples. In our case, we were given 4 different types of signals, 20 samples, and 4 different outputs that we were meant to generate. As shown here in our MATLAB codes and the outputs, this was the output that is generated.
So the next phase is we want to observe how the change of k will affect the post-zero flow. Firstly, we use the equation from phase 1 part 2, which is the convolution part, which is at a h function, h equal to 0.5n plus 0.5n with delay of k. We use this coding to show the plot by manipulate the value of k. First, we try changing the k equal to 1, and we will get a pole at the origin with 1, 0. Then we change k equal to 2, we will get a pair of 0 with pole at the origin. When k equal to 10, we will get 10, 0 on the plot. And finally, when k equal to 20, we will have a 20 number of 0 on the plot. The number of k actually is the order of denominator, where we can find after applying the Z transform into the function. By increasing the number of k, the number of 0 also increase, or we can say that number of k equal to number of 0. No matter how many number of 0 have, the number of 0 will be spread evenly in a unicircle.
For phase 3, we are using IIR filter designed to diminish the noise. One of advantage of IIR over FIR is that for the same filter complexity, the magnitude response of an IIR filter can be significantly better than that of FIR1. IIR for Bessel type filter only available for analog only, so we are using Butterworth type filter as it has steady magnitude and faster roll-off rate. As we increase the order of the filter, the slope will become steeper and the signal will become much better with a minimal noise. And here is the difference between filter order 1 and filter order 6. And for the cutoff frequency, it should be small so that the noise can be diminished. When we use 0.05 cutoff frequency, the noise cannot be diminished at all. While at 0.025 cutoff frequency, only 50% of noise can be diminished. So at 0.0125 cutoff frequency, the noise will be diminished around 95% and it will give a good signal. That's all from me. Thank you.